Okay, this will be lesson 3 of unit 5. We will be writing inequalities from words. So we have this word problem here that talks about a yearbook company promising a junior class a picnic. All they have to do is spend at least $72,000 on yearbooks and class rings. It tells us that each yearbook costs $75 and each class ring costs $375. And they want to know how many yearbooks and or class rings the junior class has to buy to get their picnic. So what is it asking us to find? How many yearbooks and class rings. We will let X be our number of yearbooks, and we'll let Y be the number of class rings. Oops. They have given us the problem again here, and they want us to highlight some numbers and fill in these blanks, or highlight these math words and math vocabulary. So we want to spend at least on yearbooks and class rings. Each yearbook costs $75. Go ahead and fill that in. And each class ring costs $375. And together those have to be at least $72,000. So down here they have written in words what our equation needs to look like. This right here is going to be a plus sign, so is this one. So we have money from the yearbook. Well, that is going to be $75 times X, because we let X be the number of yearbooks, plus $375 times Y, because that's what we let the class rings be. And it says it must be at least $72,000. At least means this is a minimum. It can't be any smaller than this. So it is your lowest possible value. So that means our sum must be bigger. So that means we need this sum to be bigger or equal to $72,000, because an at least means you can equal it, you just also must be bigger. So then they've gone through and given us a graph, but how did they get this y equals negative 0.2x plus 192? What they did was they took 75x plus 375y is greater than or equal to 72,000, and they solved for y. So remember, to solve for y, we move the x and change the sign. So this becomes negative 75x plus 72,000. Then we divide by the number in front of the y, so that's 375. So negative 75 divided by 375 is where they got the negative 0.2. And that's an x, and then 72,000 divided by 375 is 192. So because this was a greater than, we wanted to shade above the line. So basically your y-intercept's over here, we want things that are bigger than that. And we just keep shading right to the line. The line itself is included because of the equal sign. So the solution for this situation can be any ordered pair in the shaded region, or on the line. Because the line was a solid line, because this was an equal sign, this was a solid line, so we include the line in our solution set. So let's look at our next example. We have a group of friends who went to the movies. After paying for their tickets, they had a total of $12 to spend on refreshments. Sodas are $1.50 each. Popcorn is $2 each. How many sodas and boxes of popcorn can they buy with their remaining money? So we're going to let X equal our sodas, and Y is going to be our popcorn. So we can go ahead and identify those on our graph. So popcorn for our y-axis. And before I label the numbers here, I want to go ahead and make my inequality and then solve for y, so I'll know where my y-intercept is going to be, so I know how to count. So I have $1.50 for each soda, I have $2 for each box of popcorn, and I have $12 to spend. So that means this sum can't be any more than $12. So that means this sum has to be smaller than 12. So again, when I solve for y, I get 2y is less than or equal to negative 1.5x plus 12. Divide everything by 2. And we're going to get y is less than or equal to negative 0.75x plus 6. So my y-intercept is 6, so I can go ahead and count by ones. I have enough space for that. I will do the same here for the x-axis. If you go to y equals and put this in, you can get a few ordered pairs that are easy to graph, such as 4, 3, and you'll find that your x-intercept is over here at 8. So the maximum number of sodas we could get is 8, but if we do that, we don't get any popcorn. The maximum number of boxes of popcorn we can get is 6, but if we do that, we don't get any sodas. Now, because of this equal sign, when we connect these, we are going to get a solid line. The question then is, are we shading above or below? This is less than. We want things smaller than this y-intercept of 6. So this right here is my solution set. So let's look at the last four. Jordan's Christmas tree is J feet tall, Michael's is M feet tall. We have the inequality J is greater than or equal to M plus 2. So Jordan's tree is bigger than Michael's by 2 feet. So which one of these tells us that Jordan's tree is bigger than Michael's? Jordan's tree is at least 2 times. Well, this isn't multiplication, so it can't be 2 times. Jordan's tree is at least 2 feet taller. That makes sense. Let's check the others just in case. Michael's tree is more than, and that's not going to work. Michael's tree is more than 2 times. That also isn't going to work because Michael's tree is not bigger. It's Jordan's tree that is bigger. On Thursday, a student's schedule allows no more than 60 minutes for studying. Her algebra homework, A, requires 22 minutes. Her history homework, H, requires 17 minutes. Which of these best represents the time available for the student to spend on algebra and history homework on Thursdays? So, A plus H. So if we do 22 for A plus 17, that gives us 39. Is 39 bigger than 60? No. Here we have 22 plus 17, and that's 39 is less than or equal to 60. That is a true statement. 22, is that bigger than 60 minus 17? Well, 60 minus 17 is 43. That is not a true statement. H is 17, A is 22, and so is 17 less than 82? Yes, it is. So we have to decide between B and D. So the relationship here is not that her history homework has to be less than 82 minutes, because remember we have a maximum of 60 minutes, so we can't be adding that algebra to those minutes. So over here, these two together have to be smaller than 60. So that is how you would decide between those two for which one you would choose, because this has the relationship of the sum being smaller than 60, but this does not. Okay, a sports company sells golf balls in a box. The empty box weighs 6.8 ounces, so no matter how many balls we put into the box itself is always going to be 6.8. It's never going to change. Each golf ball weighs at least 2.3 ounces. At least is a minimum, so that means that the balls could weigh more. Which inequality best describes the total weight in ounces? W. So the total weight of a golf ball in terms of the number of balls in the box. So we know that we have to have 6.8 as our y-intercept. So that could work here, could work here. It cannot work here because they show 6.8 as a rate of change for these two. So it has to be one of these. When we have the box, are we adding the golf balls to it, or are we taking the golf balls and subtracting the box? Well, we're actually adding those two things together, and we want that weight to be at least 2.3. Golf ball might weigh 2.5 grams. That means your weight would be even bigger. So we want to go ahead and say that the weight is greater than or equal to this amount here. The Jones family budgeted $3,500 for their vacation. That means we have a maximum of $3,500, so this is going to give us a less than or equal to $3,500 situation. Their budget consisted of $200 a day for travel and $95 a day for other expenses. So travel costs would be X. Or sorry, the number of days is going to be X, and we have travel and we have expenses. The family could have, so they want to know which inequality represents the number of days X the family could have stayed on vacation. So we are adding 295. So they want X to be the number of days, so we're just going to say that 200 is being multiplied by X, and we want that to be smaller than 3,500. So we're not going to choose these two because they have 200 being multiplied by Y. And this one says that they're subtracting, and somehow that's going to be bigger, but you wouldn't subtract these two things. You would add them together, and together they have to be less than or equal to 3,500. So basically you have to be very careful of things like budgeted, no more than, at least, and then try to decide whether that means something is bigger or smaller and who is bigger or smaller. That will help you to eliminate some of your answer choices, and as always, when you have something in slope-intercept form, knowing which one is the intercept and which one is the rate of change will help you out tremendously in getting rid of some of those answer choices. So this is lesson 3 for unit 5, writing inequalities from words.